Hi, everybody. Welcome to another HOSS Talks FOSS. I'm here with Liquan Pei from PingCAP. How are you today, Liquan?
I'm pretty good, and I'm pretty excited to take this conversation with you.
Great, great. And so tell us a little bit about PingCAP and what you do there for those who might not know about PingCAP or TiDB.
Yes, PingCAP is a company founded in 2015, and it starts with a project called TiDB. And TiDB is, I would say, a NewSQL or HTAP database. For people who don't know about HTAP, it's a short for hybrid transactional and analytical database, which means that you can process your ORTP workload and ORAP workload in a single system. And since then, since it's funded and it starts with building the open source project, and it has attracted, I think, over 2,000 stars, and it has already over 1,000 contributors of the project. And it has been used by many companies. I think we now have over 1,500 companies has adopted TiDB in production. In short, I think TiDB is a new distributed architecture. It was inspired by Google Spanner, and it has a layered architecture. Yeah, we can go more detail about that.
Okay.
And I'm doing, I joined PingCAP in 2020, but I've been know this company a long time ago. I know the founders since the year of 2017, at that time I was at Pinterest, and we have a project, and we call it like real-time indexing. And actually, that's a good fit for TiDB. We did a quick kind of like a demo at that time. I think that is how I know about TiDB at that time. So that is kind of like some of history with TiDB. Now I'm here work as database engineer. But I do know in startups, especially, we are still early stage in the United States. I also wear multiple hats, and
Okay.
I did help with the recruiting a lot. I interviewed maybe a couple hundred candidates last year and this year. And then I also worked very closely with a few customers, especially some key customers in North America.
Yeah, and many of the former people who I've worked with in the past have gone on to work at PingCAP. Many from the MySQL space because PingCAP's protocols are MySQL's protocols. They've
Yes.
made sure to mirror those, so there's a compatibility with existing MySQL workloads.
Yes, that's a good point. I think when we build that, I think we keep in mind that we want to be MySQL compatible. I think that is kind of the original goal, because we know that MySQL is kind of the most adopted open source database, and it has a lot of usage. And I think when the founders start build TiDB, they want to make the migration easy from MySQL. Yeah.
Yeah, and we've seen that, in this new SQL space, you've got, TiDB, you've got Yugabyte, you've got Cockroach. Yugabyte and Cockroach have chosen the Postgres protocol versus the
Mhm.
MySQL protocol.
Yeah.
So, depending on where you lie on whether you prefer Postgres or MySQL, there is a solution for you.
Yeah.
But maybe tell us a little bit about what NewSQL is, because people are using MySQL today. They understand it. Why would they need to move to the next level to this new SQL version that has more features? What do they get from doing that?
Yeah, I think that's a good question. My understanding of NewSQL is really combine the advantages of the relational database, which has a transaction capability and the SQL interface, right? And the scalability of NoSQL, right? Because NoSQL excels at scaling. It's pretty easy to scale. You can add nodes, and it can handle more, can store more data and handle more traffic, right? That is kind of what NoSQL excelled at. Whereas for traditional relational database, you have the transactions, right? This simplifies a lot to developers because they can safely retry when something fails. Whereas if you don't support transaction, then you have to do a lot of additional work in order to make things correct. And
Yes.
that's one point. And the other thing is that a SQL is much easier, right? It's very expressive. You can do a lot of computations using SQL. You can do scans, you can do group bys, you can do joins, and then do analytics, right? You can do a lot of things. Even you can build machine learning libraries using SQL. So I've been working at a private company that they called Greenplum database, and they actually build machine learning library on top of SQL. So you can do a lot of things with SQL. So this definitely can speed up the developer velocity. So I think that benefits. However, traditionally scaling a SQL database is pretty hard, and people choose to use sharding. And once you go there, and the application needs to be aware of the database sharded, and you lose the transactionality across shards. So I think with NewSQL, the sharding is transparent to the user, and the user still think you are working with a single node database. But the database underlying can be scalable. You can add new nodes, and then you can move the data around and automatically. And by adding new nodes, you can scale the database, serving more traffic, and store more data. So I think overall, from the benefits to the developer is that, first of all, they're still working with SQL, and they are still mostly thinking it's a single node database. Then they have a higher developer velocity. And from the maintenance point of view, and you don't need to manage the sharding, and I think that is kind of the benefits.
Now, one of the interesting things about TiDB is it is currently a completely open source, product. So anyone can go out, try it, use it, and get the benefits of this new SQL for themselves. But you can also contribute to it. You mentioned that you have thousands of contributors worldwide. So, it's a bit of a different model than a lot of companies are following. A lot of companies right now tend to, prefer some sort of proprietary-ish or not quite open source license, if you will. So, that's one of the exciting things about that, and that can help, definitely drive adoption. But, I talked with Morgan on our podcast, Morgan Talker, not too long ago, and he was talking about some of the hackathons that, the engineers at PingCAP have put on for their community. And I was curious, have you been participating in those hackathons as well?
Unfortunately, I didn't, but I would love to. I
Okay.
think it's a pretty, I think it's a pretty fun fact. Actually, I watched a lot of videos and a lot of articles talking about the hackathon, for example, using GPUs to accelerate or AP processing and building a graph database on top of TiDB, right? Or building a file system on top of TiDB. There's a lot of interesting ideas. And also there are some features that I think customer really want, like the TTL in tables, right? This is a lot of customer want, and a lot of interesting stuff. So, yeah, I would love to do that, but I think the challenge with me is the time zone issue, really in the
Oh, yeah.
US. I think there's a lot of events actually in the APAC region, so that's kind of what I miss those things. I hope that we can have a hackathon in the local time zone so that I can really participate. But there are a lot of interesting things out of it. For example, for the GPU kind of acceleration, NVIDIA also expressed some interest in knowing more about it and see whether we can collaborate in some sense. Yeah.
So your job is working heavily. You mentioned you're doing a lot of different hats because you're a startup, but officially it's working on the database kernel itself. Is that correct?
Yes.
What sort of work are you doing recently? What sort of interesting things are you looking at?
Yes, I think one thing I was now looking at is kind of some new features in the database. For example, whether or when should we have dual partition in TiDB, yeah, and how to make TiDB more cloud native. This is something I was involved in the discussion. So yeah, so those
And
are
you're talking about cloud native in terms of being able to run on Kubernetes, automatically spin up new nodes, reshard, repartition as you need to.
yeah, this is part of it. Also, I think another thing we need to look at is that how do we build a database that leverages the cloud primitives? For example, I can give you an example. For example, right now, the TiDB is using Raft to do data replication, right? And when a node is done, when I add a new node to the system, you actually need to copy the data from the existing node to the new node so that you can serve the traffic, right? So
Yes.
that is current like architecture. But then in the cloud, you have S3s and you have other like the cloud services available. And then you can leverage that to simplify those replication. So for example, you don't have to replicate all the data. You can probably replicate your logs, right? That's enough. And all the rest can be done through the S3, right? You can use S3 and then to download. And another thing you can leverage as the cloud is that typically the TiDB is doing compactions because they are building on RocksDB. And periodically they need to do compactions to kind of make the data more better formed, I would say, right? To deduplication, to make things like more structured. So, and that is done traditionally in the same TiDB nodes as in the nodes serving the traffic. And then when you do compaction, it can have impact on the online traffic, right? However, on the cloud, you can do things differently. You can actually do remote compaction. You can, okay, so you can say that, okay, I have a few dedicated machines, and then we can ship those files in those machines and do the compaction and ship them back. So at the end of the day, though, the machine serving the traffic will consume much less CPU when doing those compactions. You actually offload the compaction into dedicated resource, and as a result, it causes like a much more stable performance to the online traffic. So those are some kind of things, the benefits of the cloud native architecture, right?
Okay, so I mean, yeah, I mean, it sounds like a lot of the stuff you're working on is kind of twofold, right? Obviously, the performance and scale is always important, but also those operations, making it easier for things to happen behind the scenes. I know that trying to spin up new nodes is always a challenge, and yes, if you can hook into some of the things that are already available in the cloud, whether they're block storage, copies, or do snapshots, or take your backups from S3 wherever, that those are always good things. And obviously anything that you can do to speed up some of the back end maintenance is also going to be helpful. But when we talk about like use cases, and you mentioned TiDB has 1,500 customers, and probably 10 times the number of users. I'm curious, is there a use case that you see that this is really popular with? Is there one or two different industries or different workloads that TiDB really excels at?
Yes, sure. I think we have like customers in the fintech space, and the customers, I think I want to maybe give it two use cases. I think one are in the fintech domain, and the other in maybe in the SaaS domain. So I think for the fintech, that there's nowadays more and more like I would say that either online banking or there's P2P or customer-facing payments, right? For example, Venmo, Square Cash App, and there are other, I believe, companies in different parts of the world. For example, there's a company called Nubank in Brazil. They are sending, they are offering credit cards. And there's another company in South America called B89. They are offering also similar to Nubank. They are offering the credit card to Spanish-speaking like customers. So I think for those companies, they want to offer good experience to the users, right? Because they are dealing with a larger user base. Yeah, and I think they are have the challenge of scaling their business. For example, one of the customers we have is in Japan, and they are an online payment company, and you can basically send money to each other. And they have met the challenge that, okay, they cannot scale during peak hours, and especially during promotions. And then they are suffering a lot about that because the scale database they were using cannot scale the rights, and then they basically cannot do the promotion. The database is done. So that they decided to use TiDB because TiDB's architecture is a master, and you can scale both read and writes. And then once they migrate to TiDB, they no longer suffer any outages when they do promotions, and TiDB can easily handle 3 times of their current scale. This is one of the examples we have, which is a fintech, the online payments, and you are offering a service to the consumers, and they can do a lot of transactions at the same time, because of it's a consumer-facing app. That's one
So
example.
fintech is an interesting space because it's one of those spaces that when you look around the industry today, everyone is concerned about, ensuring that not only do they have performance but security. And in fintech, it's one of those things that security is even
Yeah.
further along. So
Yeah.
maybe tell us a little bit about, some of the things that you're working on from a security standpoint to make sure that, the code that's going out there and the feature set can handle a bit more of a secure environment like that.
Yeah, sure. We have like the TLS between all the components and the client and the cluster. Okay. And also we have encryption at rest, which called also TDE for our storage layer. And then we have also authorization and authentication system in the TiDB layer. And beyond that, I think we also offer audit log for the users that they know what's happening in the database. So here are some features we provided in the database itself. On the cloud services, you know that we probably I should mention that we also offer hosted TiDB. We call it TiDB Cloud, and for that we have actively kind of like doing compliance stuff. So for example, we have passed SOC 2 Type 2 and also the ISO 27001 recently, and to show our continuing investment in the security. Yeah.
Okay. Yeah, I mean, it's always interesting to see because the bar for not only performance but security keeps on becoming,
Yeah.
bigger, higher and higher to clear as these systems become more critical, especially in some of these ancillary spaces.
Yeah.
But from an engineering perspective, I am curious, like what are some of the interesting, maybe fun things you've uncovered looking at the code base, for TiDB? Are there certain things that surprised you when you started to dig in? Were there things that you thought were very interesting, or that you think is pretty unique?
Okay, pretty unique. Okay. Uh, yeah, I think the pretty unique thing is usually when you work with a distributed system, some pretty simple thing can be really complicated. So that's one thing. I won't give you an example called, I'll say the bin log or change data capture, right? And I think if people has worked with MySQL, and they should be familiar with the bin log, right? And the bin
Yes.
log can be used to do data replication, set up like a the primary, secondary like architectures, right?
Yes.
So those are interesting. And I think for a distributed database like TiDB, and then if you do bin log change data capture, there's a lot of like interesting problems you may never think of when working with compared with working with a single node database. For example, because TiDB supports distributed transactions, and all the transactions can happen on different nodes, right? And if you're doing a change data capture or bin log, you can gather this data from different machines, right? But if you really want this data to be useful, you do need to output the data in a transactional order so that you can build like a primary, secondary architecture, build your DR system, right? However, then there's a challenge is that because everything is distributed, you get a lot of things like in the order of modifications, but not in the order of commits, right? You can start a transaction, and this transaction can be very long and can then committed very late, right?
And
Right.
span multiple
And, and
nodes.
then and then even you don't know when you receive everything, right? Because everything is distributed. You don't know, okay, whether I have received all the updates for this transaction, right? Then this really becomes like pretty interesting. So I think for the distributed kind of transaction, we actually utilize research actually from big data. I think there's a paper called NAIAD published by 2013 by Microsoft that they're actually building a data flow system and using the
Okay.
concept of the result timestamp. And the idea of result timestamp is that you know that before this, once you receive this, it's like a watermark in the stream processing system, telling you that once you receive this event, everything before this timestamp has been received by the downstream. Then you know that all the events are you receive all the events, then you can send them to the downstream. Other than that, you cannot send to the downstream. And this is pretty fascinating. And without this idea, you cannot really reconstruct your transactional order, right? So I think this is something I really like.
Yeah, that's interesting. I mean, in when you think of a distributed system and a distributed, SQL system, for those of us who have been in the database space, you're used to being able to monitor nodes, even if there's multiples in a cluster. But because of the distributed nature of the transactions, it can lead to other issues, not just with the, trying to piece together, the transaction logs, but also the observability has in the monitoring and being able to figure out, which potential node might be having issues or,
Mm.
trying to piece together that has to be a challenge from a back end perspective as well.
Yes, I think I totally agree with you. So uh, I think the challenge with distributed system is like uh, you have to deal with failures, right? So you have to deal with failures, and you need to make sure that your system behaves correctly with those failures. So
Yeah.
and then also because it is kind of like handling a lot of things at the same time, right? So those are understanding what happens is pretty challenging, especially where support like SQL queries, and also we support complex SQL queries. And figuring out what consume the most resources is like kind of challenging. Yeah.
Yeah, and I mean, I can imagine that it's hard enough sometimes to find the problem area
Yeah, and
in
also you know that there are there's a lot of kind of like background works like compaction, like the garbage collection, yeah,
yeah.
like the synchronization between the column store and row store, right? There's a lot of backend, and then the replication, then the transaction logic, right? It's kind of like a lot of things going on at the same time, and beyond that, there's constant failures. You do need to move data around, and you do need to understand the environment in all this kind of dynamic in this very dynamic environment, and ensure everything is correct even with all this dynamic correct. Imagine the case that you still want to support ACID, right, for all the transactions, given that the data is constantly moving, there's constantly failures, there's constantly retries. So there's the region splits, region merge, right? So that is kind of what really I do really like.
Yeah, I mean, it's fascinating because as you start to go in as a database person, as someone who's running this, to be able to understand where a problem is, where the issue is always that interesting step that from an engineering perspective, you try and fix those without escalating them up or letting people know about them, but
Yeah.
eventually someone's looking for
Yeah. I think that's the beauty of
some.
the database. You hide a lot of complexities inside, right? And for the user,
Yeah.
user see, okay, I think we are just running SQL. And I think for a lot of like, I'll say, I've been working with people from working mostly in the upper level in previous companies. So they are really mostly dealing with the running SQL queries, not running the writing SQL queries. They would think that SQL system is pretty magic, and but I mean, for a database person, it's really like they had a lot of complexity there. So
Yeah.
yeah.
Ah, very cool. Well, Liquan, I want to thank you for stopping by and giving us a little bit of an overview of TiDB and some of the things you're working on. Always good to catch up. Appreciate you stopping by.
Sure. Thank you.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.